This is a video I'm doing for a pre-calculus or math analysis type class. And in this video, we're going to be going over trigonometric functions, properties, and equations, as well as a brief introduction to angles. So an angle is comprised of something called two rays, which are two line segments that are joined at a single point. This point is called the vertex, and these two lines protruding from the vertex, like I said, are called rays. And how far around a circle you have to go to get from one ray to the other is the measure of the angle. A good example of this would be an angle of 180 degrees. We have one ray going this way, and a circle has 360 degrees. So a 180 degree angle consists of a semicircle, and then you would connect one ray to the other end of the circle, and now we have our 180 degree angle. So again, like I said, a circle has 360 degrees. I'm going to go ahead and put that up here. But another way we can describe angles is by using radians. One unit is degrees, the other unit is radians, and a circle has 2 pi radians. So if we go a fourth of the way around the circle to this point here, that would be a fourth of the way around the circle this way. This angle is 90 degrees because that's 360 divided by 4, and it's pi over 2 radians because it is 2 pi over 4, which is pi over 2. So really quickly, before we move on to sine, cosine, and tangent, let's do a couple of example problems where we have to convert radians to degrees and degrees to radians. So here we have our two examples. The first example asks us to convert 9 pi over 2 to degrees. So what we're going to do is we're going to have 9 pi over 2, and we're going to multiply 360 over 2 pi. What this does is we are taking the 9 pi radians here. We could put a little note here that says radians, and this is 2 pi radians. This is our conversion factor, similar to what you would do in a science class. And we have 360 degrees, but now our radians cancel, and our pi's also cancel, so we're left with 9 times 360 over 4 degrees. And that gives us 810 degrees. So 9 pi over 2 radians is 810 degrees. Similarly, if we want to convert 740 degrees to radians, we take the number and we multiply it by 2 pi over 360 degrees, and our degrees cancel here, and we are left with radians. Some other things also cancel here. This multiple of 10 cancels, and we're left with 74 times 2 over 36. And that'll give us 37 over 9 pi radians. So 740 degrees is 37 over 9 pi radians. Now that we've done a couple of examples of how to convert these, let's move on to sine, cosine, and tangent. So a sine of an angle, we'll call this angle here theta, is equivalent to the opposite of that angle, so the side of this triangle that's opposite our angle, divided by its hypotenuse. So we'll have the sine of theta is equal to O over H. And how do we know which one's O and which one's H? Well, we look at this triangle, and whichever one is directly across from this angle theta is the opposite. So if we took a line and we bisected these two rays, we put this line right between those two rays, whichever line it touched, that's the opposite. And the hypotenuse is the same, but for the right angle in the triangle. So in this case, I've outlined the right angle in blue, and we can bisect the right angle, and that takes us right to the hypotenuse. Similarly, the cosine of theta is equal to the adjacent over the hypotenuse. And again, the adjacent is the opposite of the other angle in the triangle that I'll highlight in orange here. Or it's the ray that is connected to theta that's not the hypotenuse. So very clearly, this ray here is the hypotenuse, this ray that I will color in green. This is the hypotenuse of this triangle. And so the adjacent is the other line segment that is connected to theta that isn't the hypotenuse. So that's this line that I'll highlight in orange here. But now the tangent of theta is equal to the opposite over the adjacent in this triangle. So again, that's the angle directly opposed to theta and the ray that is touching theta that's not the hypotenuse. Another way we can write tangent theta is sine theta over cosine theta. But if we take sine theta over cosine theta, that gives us O over H divided by a over h, but then simplifying that, we just get O over a, which is exactly what we wanted. And if you were in an American middle school or high school, this is where you would get something that we call SOHCAHTOA, which is sine is equal to opposite over hypotenuse. That's sine opposite hypotenuse. Cosine is adjacent over hypotenuse, CAH. And then the TOA is tangent is opposite over adjacent, which is tangent opposite adjacent. That's where we get this acronym here. And that acronym can really help you if you're struggling to remember the definitions for these trigonometric functions. In the next video, we'll talk about the unit circle and how we can apply sine, cosine, and tangent. That's enough for now.